In this video you will learn how to perform a hypothesis testing for population means of more than two populations.
The test is an F-test, or simply known as ANOVA.
Assumptions that the ANOVA to be valid are: 1. The population from which the samples were obtained must be normally or approximately normally distributed. 2. The variances of the populations must be equal. 3. The samples must be independent of one another.
The null hypothesis is: all of the population means are equal. And the alternative hypothesis is: at least one mean is different from the others. Or a pair of mu I is not equal to mu j for some ij.
The F-test statistic is easier to calculate by using the ANOVA table. The table consists of columns showing source of variation, sum of squares, degree of freedom, mean squares, F-test statistic.
We need to find treatment sum of square denoted by SS treatment, error sum of squares denoted by SS error, total sum of squares denoted by SS total, the degree of freedom for treatment, which is number of means tested minus 1, the degree of freedom for error, which is number of observations in the sample minus the number of means tested, the degree of freedom for total, which is number of observations in the sample minus 1, mean square treatment, which is treatment sum of square divided by its degree of freedom, mean square error, which is error sum of squares divided by its degree of freedom, F, which is equals to mean square treatment divided by mean square error. We reject the null hypothesis for large F.
Example: an experiment on a helicopter toy model with 3 types of wingspan were conducted. The flight time were recorded and the data are as shown here. Is there any difference in the flight time for the 3 types of wingspan? Test at 5% significance level.
We start the calculation by arranging the data according to the type of wings.
Calculate the sum for each type of wing. The notation is sigma yi.
For type A, the sum is 46.46.
For type B, the sum is 69.77.
For type C, the sum is 54.93.
Next, for each type of wing, calculate the square of the sum divided by the sample size.
For type A, 46.46 square divided by 5, which is equals to 431.7063.
For type B, 69.77 square divided by 5, which is equals to 973.5706.
For type C, 54.93 square divided by 5, which is equals to 603.4610. Next, get the total across the columns for each row. For the row of sigma y, the total is 171.16. For the row of the square of the sum divided by the sample size, the total is 2008.7379. Calculate the sum of squares for all observation. That is double sigma y square, which is equals to 2080.8786. The number of observations is 15.
Next, calculate the correction factor, denoted by CF, which is the total for all of the observation square divided by the number of observation. Here it is 171.16 square divided by 15, which is equals to 1953.0497. Sum of square of treatment is total of the square of the sum divided by the sample size minus CF, which is 2008.7379 minus CF, equals to 55.6882. Sum of square for total denoted by SST is the sum of squares of the observations minus CF, which is 2080.8786 minus CF, equals to 127.8289.
Putting all of the values into the ANOVA table. Starting with treatment sum of squares. Total sum of squares. Error sum of squares is the total sum of squares minus treatment sum of square. which is 127.8289 minus 55.6882 equals to 72.1407. The degree of freedom for total is 15 minus 1, which is equals to 14. The degree of freedom for treatment is 3 minus 1, which is equals to 2. The degree of freedom for error 14 minus 2, which is equals to 12. The mean square of treatment is 55.6882 divided by 2, which is equals to 27.84409. The mean square error is 72.1407 divided by 12, which is equals to 6.01173. The F statistic is 27.84409 divided by 6.01173, which is equals to 4.6316.
Putting all the informations together. At alpha 0.05, the critical value is 3.89. We reject the null hypothesis since the test statistic is inside the critical region. Conclusion: there is enough evidence to conclude that there is a difference in mean flight time between types of wingspan.
Thank you for watching.